folks, welcome to example 7. So we're going to take a look at solving this quadratic inequality, but this time out, I'm not going to be able to factor this quadratic. I did that intentionally. I want to get a little bit messier. All right, so we're still going to make a sign pattern, all the same stuff, but it's just going to be a little bit messier. So if I saw this quadratic inequality initially, I'd say, okay, let me see when this thing zeroes out, what specific x values am I looking for, right? And I'd say, all right, I'm going to try and factor it. So I'm going to take the negative out because me personally, I don't like a lead negative when I'm factoring. And I'd even get to the point where I was like, this is my jam. I see x minus 7 here, x plus 1. This is looking good. I'm feeling good about factoring. But the problem is, while outer and inner, right, positive x and negative 7x do add to negative 6x, the problem is if you look at last, negative 7 times positive 1 is not a positive 7. So this is a problem. This I couldn't factor. And that's okay because we always have the quadratic formula, right? Factoring is a little bit faster if it works, and if it doesn't, then we go with the quadratic formula. So here, so let me get rid of my eraser, right? I'm gonna say A is negative 1, B is 6, C is negative 7. And let's see if we can do this. So I'm going to have x is going to equal negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, so let me clean this up a little bit. Okay, 6 squared is 36. This is 36 ultimately minus 28 because I have negative, negative, negative. 36 minus 28 is going to be 8. So I am looking at negative 6 plus or minus the square root of 8 over negative 2. Now negative 8 I can simplify a little bit because negative 8 is, if I think about that radicand, meaning the stuff under the radical, that is 4 times 2. 4 is a perfect square, so it can come out as a 2. So I will have negative 6 plus or minus 2 root 2 over negative 2. And I'm going to divide this. All right, but remember, I got to divide the negative 2 into both parts. So I need to take 6 plus 2 root 2 over negative 2, and then I need to take 6 minus 2 root 2 in ratio to negative 2. All right, that's what these turn into. All right, and then, oh, I just saw I dropped a negative. Let me put a negative here and a negative here. Okay, so every time out, negative 6 over negative 2 is ultimately going to be 3. All right, when I have 2 root 2 over 2, that's going to simplify to root 2 because the 2's are going to cancel. Here will give me a positive version because I have a positive over a negative. Here I have a negative over a negative, so that would be the positive version, right? Positive over negative leaves a negative. Negative over negative leaves a positive. So this is ultimately 3 plus or minus the square root of 2. So the two x values I'm actually going to put onto my sign pattern now are going to be 3 plus root 2 and 3 minus root 2. All right, so 3 is right in the center of them. Here's going to be my little smushed xy axis. All right, I always put my x coordinates below that number line, and then my y coordinates are really oh my gosh, I can use my words, the quadratic expression above. And then I'm going to have 3 plus root 2 over here and 3 minus root 2 here. And you can think 3 is in the middle of that, right? Because I would add a root 2 to get up here and I'd subtract a root 2 to get down here. Okay, but when x was 3 minus root 2, this expression was 0. That's how we found it in the first place, right? We set this equal to 0 and got these two x coordinates. Same with 3 plus root 2. When x was 3 plus root 2, this expression was 0. Okay, so then what I need to do is figure out, do I put a plus or minus here, plus or minus here, plus or minus here? So let me think about a number to the right of 3 plus root 2. So root 2 itself is about 1.4. So 3 plus root 2 is about 4.4-ish. And if I wasn't sure, right, if you're like, I'm not sure that I would have had that in my head, no worries. You can head over to your calculator and do 3 plus the square root of 2. And you can type in the number 2. And see, it's about 4.4. Because I've done the square root of 2 so many times in my life that I know it's about 1.4. So 3 plus it would be about 4.4. Okay, and where I'm going with this is maybe I pick 6 as a test point. I could have picked 5, I could have picked 17, but when x is 6, what is this value in terms of if it's positive, or is it positive or negative? And usually I like to put these test points into the factored form, but I just don't have it this time. So I'll put it into the original, but I am going to use my calculator. So I'm going to take 6 and I'm going to store that value in x so that I can do negative x squared plus 6x minus 7. And I'm going to scooch this up for a bit. I can't always get this in. If you haven't seen the store function, I'm confident I have it on previous videos, but take a look. It's STO right here. It's above your on key. All right. So I've got this store function. I'm going to see, was this positive or negative? So it looks like this was negative. Okay, great. I'll put the minus sign here. Now, what's a number in between 3 minus root 2 and 3 plus root 2? Well, this is about 4.4. Right? And if I think about 3 minus 1.4, that's about like, I think 1.6. And if I'm not sure, then just crunch it on your calculator. 3 minus the square root of 2 is going to be about 1.6. So I need a number that's somewhere in between 1.6 and 4.4. I'm just going to pick 3. I know 3 is in the middle. So let's plug 3 in here and just see if I have a positive or negative. So if I store 3 into x and then I run that expression again, it looks like I have a positive number now. So I'll put the plus sign there. Okay. And we said this was about 1.6 as a number. So I'm going to try a number to the left of that. I'm going to just try 0. Anytime I can plug in 0 or 1, I tend to go for that because those seem like the easiest numbers to plug in. 0, 0, negative. Right, so it looks like my sign pattern as I went left to right went minus, plus, minus. And I can imagine my graph went below the x-axis, above the x-axis, below the x-axis. And I know I have a lead negative coefficient, so I'm going to have an upside down parabola. So that makes sense for me. Now I like to clean up my sign pattern, so I don't usually leave my test points. You don't have to do this. I just like to do this. I like having things neat and orderly if you haven't figured that out. All right. And before I go any further, I am just going to graph this on my calculator. It looks like I've already got it in there. I'm so smart. I'm going to hit Zoom 6. That was a terrible Boston accent. If you are from Massachusetts and the Boston area, I apologize. All right. That could be 3 minus root 2. That's about 1.6. And this is about 4.4. So I think I've graphed that correctly. And I did go below, above, below. Oops, excuse me, let me do this again. Below, above, below, crossing the x-axis twice. So far my algebra work is matching my graph. That's a good thing. All right, now let's look here. Now let's look at the actual inequality, right? So once you get everything graphed out on a sign pattern, the last phase of these problems is to look at what does the inequality say? And in this particular problem, it wants things that are greater than or equal to 0, which is fine. But what we're going to do is we're going to look, at least on our sign patterns, I'm going to look for the plus signs, right? And I'm going to look for the zeros. So let me see where those are. I can see some zeros here. I want to include these. All right, and then I want plus signs, so I want this one. Okay, and that's all fine and good. So that shows me that my endgame answers are 3 minus root 2 to 3 plus root 2. And I'm going to put brackets around those because I do want to include them because of the equals to 0. Okay, thanks so much. Bye.